everyone, we're going to be talking about exponential versus quadratic versus linear equations. These are three different types of equations that we've learned about this year already. And so let's just go through kind of the differences that we have. In a linear equation creates a line on a graph. So if I have a graph, it's just a straight line. It can be going up, it can be going down, it can be going right and left, but it just creates a straight line. The general equation for linear is y is equal to mx plus b. We've looked and talked about this year. The big thing to understand is that there's no exponents in these equations, and that is what signifies that it's linear. So then we talked about quadratic equations, and quadratic equations on a graph create a parabola. So the parabola can be turned upwards or downwards. It doesn't really matter, like create an upside down U, a right side up U. And the general equation for a quadratic formula is y is equal to ax squared plus bx plus c. So you have an exponent, and the highest exponent is 2. You don't necessarily need to have all three sections to it, just as long as you have something with an x squared that is considered quadratic. And then the last equation that we're going to talk about, which is what we're learning in this lesson, is the exponential equation. So in an exponential graph, it rises or falls really fast. So it can look like this, where it's kind of like it almost creates like an L looking thing that goes from low, close to 0, all the way up. Or you can even I'm going to just do it kind of over here on the side, like it can start up and move all the way down and create kind of backwards from what that looks like. And we did learn how to graph these a couple of videos ago. The general equation for an exponential graph is y is equal to a times b to the power of x, like we learned in a previous video. And the exponent on these ones, it has to have an x in the exponent in order to be exponential. All of this information is on one of your cheat sheets as well. So for this self-check and for these examples, we're just going to go through some different options and determine which ones are linear, which ones are quadratic, and which ones are exponential. So for the first example, we have three different equations. Fx is equal to negative 4x squared plus 3x minus 2. Gx is equal to 2x minus 1. And hx is equal to 4 to the power of x minus 5. And we have to decide whether these equations are linear, quadratic, or exponential. So when I look at these, I'm going to kind of decide based on what the exponents look like. On that first equation, the highest exponent is a 2, and that should automatically signify that this is a quadratic equation. So I'm just going to put a Q right next to it. Then the second equation is a 2x minus 1. So this one doesn't have any exponents. And the only thing that we've talked about that doesn't have exponents is a linear equation. So I know that second equation is considered linear. Then the last equation is 4 to the power of x minus 5. Because it has an exponent of x, then it automatically has to be exponential, which means that I'm going to put an e next to it. All right, so now let's look at the second example. This example has graphs on it. So the first graph is a straight line. It's going upwards, but because it creates a straight line and there's no curve to it, we know that this is linear. And then this middle graph has a curve, but it starts out really slow and then grows really fast. That is a sign of an exponential graph. And then the last one is a parabola, which means that it's a quadratic graph. Again, all of these should be on your cheat sheet, so during your self-check you can kind of refer back to that. Okay, the last two example questions, we have to use these three equations and determine a couple of things about them. So the three equations are f of x is equal to 3x squared, g of x is equal to 3 to the power of x, and h of x is equal to 3x plus 3. So for the third example, we need to determine which one has the largest y-intercept. So potentially we could graph all of these. And in fact, let's just do that right now, just so you can see what's happening. So when we graph these, we're going to call f of x my blue graph, and then we'll do g of x as my green graph, and h of x as my red graph. So for my blue graph, we have 3x squared, and that is a quadratic graph. It starts at 0, and then it'll go up 3 and up over 1, and it kind of goes tight and skinny like this. Then for my green graph, that's 3 to the power of x. So if you remember from graphing exponentials, that means we start at 1, 0, and then it'll go up 3 more and over 1, and then up and over. It's going to kind of end up going really, really tight. I'm kind of guesstimating where the points are going to be, but it'll look kind of like this. And then for my red graph, we have 3x plus 3, so I start at 3 on my y-axis, and then I go up 3 and over 1, up 3 and over 1, or I could go down 3 and backwards 1. That one kind of curves, it shouldn't curve, but that is my linear graph. So these are all my different graphs. Now, it's a little bit easier to see when we have a graph, but which one has the largest y-intercept, or which one starts the highest on the y-axis? Well, that's obviously the red graph, which means my linear graph. And then the question 4 is asking for the function with the most rapid rate of growth, or the largest growth rate, which basically means which one is growing the fastest. And I know from my graph it's a little bit harder to see, but I am going to tell you your exponential graph will always grow the fastest, which means that my largest growth rate is exponential. Quadratic does grow really fast. That blue graph is growing really fast along with the green graph, but the green graph will always, always, always beat the blue graph, or exponential will always beat quadratic. And there we have it, how to compare linear, quadratic, and exponential graphs.